Okay, so we know where our data lives, we know how to find it, we know how to share it in ways that our other collaborators. Okay, so we know where our data lives, we know how to find it, and we know some good practices for how to make it findable by other collaborators. Let's just wrap up by talking about actually how do we get that raw data into a data frame in R. So the most common type of file that you are going to see data in, the way that it's usually shared with people, is a CSV file, which stands for comma-separated values. And that literally just means that when you have these observations that are in the data set, they're separated on each line by a comma, just like you see here with the name and age of these two men, Bob and Joe. Now sometimes you also see data shared in a plain text file, that's a .txt extension usually. Sometimes that literally does mean plain text. Sometimes it means words or something like that. And in fact, in some of your practice activities, you're doing these decoding activities that are coming from plain text files with words with secret messages. But that's not necessarily what it is. Sometimes it is data that is in this comma-separated form. It just hasn't been saved in that particular file type. Or it doesn't even have to be separated by a comma. You can imagine in this data set of names and ages, instead of a comma, I could use a bar, or I could use white space, or I could use really any symbol at all to denote where we move on from one observation to the next one. And so if you're going to read in an ambiguous file like a .txt, you're going to have to additionally let R know what to look for. What is the format of this data? What symbols are being used to separate those values? And then lastly, you're probably familiar with spreadsheets in Microsoft Excel, or possibly in Google Sheets, which is somewhat similar. These file types typically have the extension .xls or .xlsx. These are a little bit annoying to read into R. There's one shortcut, which is that if you open them up in Microsoft Excel, you can just go File, Save As, and save it as a CSV. And then it's just going to be read in the same way any CSV would be. There is a bit more of an elegant approach, which uses this read Excel package that we'll go over today. So let's start at the most simple and basic functions. These are functions in base R, read.csv and read.table. So read.csv, as we saw in some of the previous examples, you give it the URL or the path where that CSV file lives, and then it reads it in as a data frame in R. And if you have a more ambiguous file, maybe where the separators are not actually commas, where there's some other symbol, you can use this read.table. And then you have that extra argument called sep, which is where you tell R what that symbol is that's going to separate your data. Now those two functions are from base R, and they work just fine, but I think that the tidyverse functions are a little more elegant, a little more predictable, a little less prone to kind of hidden errors. So the function in the tidyverse that does load with the tidyverse is called readR. And in readR you have this read_CSV, which is basically the same as read.csv. It does take a URL or a path in the exact same way. There's some slightly different optional arguments that let you be really precise with your reading in. You'll practice some of those today. There's also a shortcut read_tsv because tab separated data is common. There's a read_table, and you want to be careful because this is not the same as the read.table. This is not general, this is for data separated by white space. The more general one, if you have some kind of unusual character that's separating your data, is read_delim. That delim is delimiter. It's the symbol that's delimiting the separation between the values. And then lastly, if you load up the read Excel package, and that one you'll have to install and load separately because it's not in the tidyverse, then you'll have access to this function read_Excel, which will read in, again, from a path or a URL, specifically an Excel file. So I've asked you to download this age datasets. It was a set of 4 datasets, all of which contain names and ages of 5 men. And it's the same data, but each one is stored slightly differently. So the first thing I want you to do is figure out how to read in these 4 datasets. Now the first one is a CSV, that's straightforward, but the rest of them you'll have to figure out the best way to read it in. Now you can use either read.csv, the base R functions, or the tidyverse ones. If you don't have an opinion right now, I really want to encourage you to use the tidyverse ones. And then once you finish that, I want you to snoop out this optional argument strings as factors. This is partially because this is kind of a funny joke in the R community, this argument, but it's also one that can get you into trouble if you use it wrong. So play around with that optional argument, change it up, see what changes with your data set. And then lastly, see if you can find a way to manually tell R what data types you want these variables to be. So using read_CSV, we can read in ages.csv, and if you leave it to its own devices, it's going to choose a data type for these two variables, name and age. And it should choose name to be a character vector, it's just the names of some men. And it should choose age to be either a double or an integer, it's just some numbers representing their age. But we can say, hey R, I wanted name to be a factor. I want this person not to be the name Joe, but the category of Joe. It doesn't really make sense, but it's possible. And we could read age in as a character if we want, right? If we think of the age of 35 as a string instead of the number 35. So see if you can figure out how to do that manually. I realize in this data it's maybe not super helpful, but you run into data where R tries to recognize what type it is and maybe gets it wrong, or maybe you're trying to treat it a little differently. And it might be helpful to tell read CSV what those data types are.